Exercise 6.5, question number 1. We need to find the parametric form of vector equation and Cartesian equation of a line through. So this I will treat as A vector. Perpendicular to two lines are given. Call this direction as B and this direction as D. Direction of the required line will be B cross D. How do we say that? See, B is one direction, D is another direction. Let me see. See somewhat like this way. B is one direction, D is another direction. This line is perpendicular to both, means the line is like this. Already we know for B and D, B cross D only perpendicular. So B cross D is perpendicular to B and D, and this given line is also perpendicular to B and D, means these two are parallel. So the required line will have the direction B cross D. So let us remember, whenever they give you perpendicular to two lines, find the cross product of the direction. So I will get B cross D equals to I, J, K. B vector numbers 2, minus 2, 1. D vector is 1, 2, 2. Expanding the determinant, it is I into hide the row and column, minus 4, minus 2. Minus J into hide the row and column, 4 minus 1. Plus K into hide the row and column, 4 plus 2. So we get minus 6I minus 3J plus 6K. So this is B cross D. So the line is through A vector, that is 5I plus 2J plus 8K, and parallel to, let us write the direction, minus 6I minus 3J plus 6K. So now what would be the line equation? R vector is equal to 5I plus 2J plus 8K plus SRT, anything I can write. Already they have used S and T. So put some other constant, say lambda into minus 6I minus 3J plus 6K. So let us remember, a line perpendicular to two lines means find out the cross product of the direction. That will be the direction of the line. I know the point, I know the direction. R vector equal to point plus some constant into direction. Now my question is Cartesian equation. How to write the Cartesian equation? The formula is x minus x1 by b1, y minus y1 by b2, z minus z1 by b3. These are all the directions. The numerator we say point. So this only we call x1, y1, z1. So how do I write it? X minus 5 by direction minus 6. Y minus 2 by direction minus 3. Z minus 8 by the direction 6. So this is the Cartesian equation of the line. Question number 2. Question number 3. Given x minus 1 by 2, y plus 1 by 3, z minus 1 by 4 and x minus 3 by 1 equals y minus m by 2 equals z intersect at a point. Find m. Now from the first line, so call this is first line and this is second line. What is the point that I get? A vector, change the symbol. I get I minus j plus k. Or if I write point wise, it is 1 minus 1, 1. And what is C vector from here? Changing the symbol. I can say minus 3 means plus 3i plus mj and no k at all. Or I could even say in point format it is 3 comma m for us to remember. No z value, we call it as 0. Now directions. What this is point. Denominator for direction I call b vector 2i plus 3j plus 4k. And d vector 1i plus 2j, no number implies 1, so that is 1k. Having known C, A, B, D, for intersecting, condition is C minus A dot B cross D equals to 0. So let me find out what is C minus A. What is C minus A? 3i plus mj minus, what is A vector? I minus j plus k. As I subtract, 3i minus I is 2i plus j into, here it is m, minus of minus 1 is plus 1. And there is no k here, minus k. So I have, this is C minus A vector. I want to find out the dot product with B cross D. So C minus A dot B cross D. I can say C minus A, it is 2, J value m plus 1 and K is minus 1. B components 2, 3, 4. D components 1, 2, 1 and equal to 0 since the lines intersect. Is the idea clear? Whenever they give you the lines intersect, the triple product is equal to 0. Expanding now, the symbols are plus, minus, plus. 2 into, hide the row and column, 3 minus 8 minus m plus 1 into, hide the row and column, 2 minus 4 minus 1 into, again hide the row and column, 4 minus 3 equals to 0. Expand this to get m value. 2 into minus 5 minus m plus 1 into minus 2 minus 1 into 1 equal to 0. This minus and minus I can cancel. Minus 10, 2 into m, 2m, 2 into 1, 2, minus 1 equals to 0. Or we get 2m minus 11 plus 2, minus 9 equal to 0, or 2m equals to 9, or m is equal to 9 by 2. So we have got what is m value given the two lines intersect. So what is the condition for intersection? C minus A dot B cross D equals to 0. Using the condition, we have found m is 9 by 2. Question number 4. Show that x minus 3 by 3 equals y minus 3 by minus 1 and z minus 1 equals to 0. Similarly, the other line is given, are intersecting, and we need to find the point of intersection. First of all, let us restructure this idea. Whenever they give you some coordinate, this way equals to 0, we rewrite z minus 1 by 0 along with this. So the first line is x minus 3 by 3, y minus 3 by minus 1 equals z minus 1 by 0. The second line is x minus 6 by 2 equals z minus 1 by 3. Even before that, there is y. Y minus 2 by 0 equals to z minus 1 by 3. So this is proper reframing the lines. X, y, z should be positive before I proceed. Now they have given they intersect. So we need to find what is the point and what is the direction. So A represents the point, Changing the symbol, it is 3i plus 3j plus k. B is the direction in the denominator, 3i minus j. Similarly, here the point is numerator, change the symbol, 6i plus 2j plus k. And denominator, the direction, 2i, 0j, you forget, plus 3k. Having got what is C, A, B, D, find out C minus A. C vector 6i plus 2j plus k minus A vector 3i plus 3j plus k. Subtract 6i minus 3i, 3i, 2j minus 3j minus j, k minus k is 0. Now I need to find out C minus A dot B cross D. That is C minus A, 3 minus 1, J component missing, so 0. B cross D, B vector 3 minus 1, 0. And D vector is 2, 0, 3. As I see, I need not even expand. The answer is 0. Why? 2 rows are identical. So whenever 2 rows are identical, I need not expand. It is naturally 0. So I am able to show the 2 lines are intersecting. So whenever C minus A dot B cross D is equal to 0, the 2 lines are intersecting. Now the question is, find the point of intersection. Take the first line, x minus 3 by 3, y minus 3 by minus 1, z minus 1 by 0, put it equals to t. How to write the point? Let us remember, hide y and z. 3t plus 3. So I write the point, 3t plus 3. Hide x and z. Minus t plus 3. Hide x and y. 0t plus 1, or simply I say 1 lies on 1. So this is first equation. Similarly, write the second equation, x minus 6 by 2, y minus 2 by 0, z minus 1 by 3. What is the point that I get? Take this as yes. So what is the point that I get from here? I have to hide y and z. 2s plus 6. So the point is 2s plus 6. Hide x and z. 0s plus 2, or simply I say 2. Hide x and y. 3s plus 1. So the second line, the point is 2s plus 6, 2, 3s plus 1 lies on 2. My question is point of intersection. For the point of intersection, both must be equal. 3t plus 3 minus t plus 3, 1 should be equal to 2s plus 6, 2, 3s plus 1. Compare the coordinates, x and x, y and y, z and z. Whichever is convenient for me. So let me compare these two. Y and y value. Minus t plus 3 equals to 2. Or minus t equals 2 minus 3. Minus t equals minus 1. T is equal to 1. You can also compare z and z value. 1 equals 3s plus 1. Or 3s equals 1 minus 1, that is 0. Or s is equal to 0. If I get t, put it in t coefficient. That is 3t plus 3 minus t plus 3, 1. Put t is equal to 1. I get the point is 3 plus 3, comma, minus 1 plus 3, comma 1. That is 6, 2, 1. So what is the point that we get? 6, 2, 1. If you want, you can cross verify by putting S0 here. So what is the point? 2s plus 6, 2, 3s plus 1. This is extra only for verification. So 0 plus 6, 2, 0 plus 1. My answer is still 6 to 1. So in the future problems, either S or T, any one you find is enough. If I find T, put it in T coordinates. If I find S, put it in S coordinates. The answer is one and the same, so this is not needed. Any one answer is enough for us.